Hey there, welcome to another video. This one will be the learning module Portfolio Mathematics, right? That's the next on the sequence of the CFA Level I curriculum, right? It's, again, I believe, like I mentioned before, right, that the CFA Institute decided now to kind of break more the content in different lessons than before. Therefore, that's why I believe Portfolio Mathematics became a particular lesson for the exam that you're taking. But on the other hand, it's like the previous one, it's a short topic. Okay, there's not much here to cover. Right, you're gonna see that the learning outcomes very short learning outcomes, very few key points. Okay, and some of the points we already mentioned before. All right, so let's go. Let's see here. Let's start with the slides and see the learning outcomes and the key points. All right, friends, there we go. So those are the learning outcomes on this module. So then you have what? Calculate, interpret the standard deviation, covariance, correlation, shortfall risk, right? What else they call here? Safety first risk. So again, let me summarize those learning outcomes for you here, right? So it's mentioning again the standard deviation, the covariance, right? And the correlation or returns of a portfolio. Again, this topic. So I mentioned to you, it's important that you put in your pocket the formula of covariance to correlation, correlation to covariance. That's some very important form. Now, the formula to compute the covariance, which you're going to have to do the difference of the observations of the independent variable, one of the variables, and the average of those variables, and the other variables with the average of the variables, multiply, add, divided by the number of observations, then you can get the covariance. It's a long process, and I believe that that's not going to be included in the exam to calculate covariance. Maybe if you have, like, say, two events, or just like a very small sample of A and B, for example. Very small sample of variable A, like 3 elements, very small sample of B, 3 elements. Then you can do the average, then you can do the deviations, then you can multiply, then you can add, divide, maybe. But I think it's a very mechanical process for you to show how to compute the covariance, and that goes also for the variance. Computational variance that has several steps: calculate the deviations, square the deviations, add, divided by the number of observations, or the number of observation minus 1 if it's a sample. That's your variance, and then you do the square root and take the standard deviation. It's important to practice that maybe once or twice. The ecosystem, you're going to have scenarios that you're going to be able to show that how to compute covariance, correlations. But I believe that's more important here is the conceptual component of covariance and correlation. Okay, although learning modules, learning outcomes 1 and 2 says calculate. Okay, but they also says interpret. Okay. And the last one is shortfall risk, safety first, and the ROI safety first criteria. So this is actually, I believe, that might have a chance of some of you get a question on this topic here, right? Of the safety risk or the safety criteria that we use. That's a preliminary way of choosing portfolios, right? Using some criteria, right? You're going to learn about the Sharpe ratio later on, trainer ratio, other ratios. Here we're starting with ROI safety criteria. That's, in my opinion, that's the star of the learning module, Portfolio Mathematics. Okay, let's see what we have here for key points. Not many, huh? So expected return and variance or returns. Again, it's important to understand how to compute, compute the expected return, how to compute variances, standard deviations. But I think the computation itself, per se, I don't think will be in the exam. Like a quick expected return, maybe, multiply the expectations or the weights times the return of each asset, get the expected return, things like that. But I think you're going to also have the chance to do that in particular in topics is more specific, such as equity, for example. And we have to calculate the expected return and then use it for answer some kind of questions there. Okay, so covariance, correlation, again, make sure that you understand, right, how you go from covariance to correlation covariance. That's, I think it's important, right? And the portfolio risk measurements here. The application of the normal distribution, I don't think it's going to be so much of a scenario here. It's going to be more of the joint probability, the safety criteria, covariance and correlation are going to be the stars of your of this video here, this module. Okay, well, let's go to my points regarding Learning Module 5 Portfolio Mathematics. So the points that I want to stress here, okay, it's the not calculate, but more interpret the covariance and correlation, the shortfall risk, safety first ratios, and the ROI criteria. Those are the ones that I want to focus on the video. The key points, right? It's understand the portfolio expected return and variance, which you already did. That's the third time we mentioning this in a learning objective. Right? So that means attention on expected return and variance. Again, I insist, I don't believe that the calculation of the variance, the long variance calculation, would be a question for you. Interpretation of the variance, the combination of variance and standard and expected return, things like that, that's definitely more important in my opinion. Look, the form of the covariance, right? Covariance is always two elements, so A and B, X and Y. So here I have X and Y being subtracted from the respective means, now the respective averages. So X should be an X bar minus X. That's the difference between X and the average, the expected X, okay? And the Y is the same deal. Then you take all those deviations from X, deviations of Y, and multiply each deviation, right? They multiply each deviation, added, and then you divide it by, if it's a sample, n minus 1, as you're showing here, okay? So if it's a sample, you divide it by n minus 1. If it's a population, you divide by n. All right. Correlation, then once you have the covariance, you just divided the covariance by the standard deviations of each variable, and then you have the correlation. So in other words, the correlation is a standardization of the covariance. We standardize the covariance based on standard deviation. All right. Correlation of returns, okay? It's important. Covariance giving a joint probability function. What it means is, or like we said, the normal distribution, etc. This one I found a little bit too much, maybe, okay? Would face a question, okay? But again, you're gonna have the time to practice questions with correlation returns in the normal distribution in the ecosystem. I decided not to include one here as an example, okay? But I decided to kind of talk about it, and see if you can get, right, what is correlation returns related to the covariance in a joint probability function, meaning steps. Correlation is the covariance is standardized by the standard deviation, right? So that's the relation between correlation and covariance. Now, the question here, or the point is, what is the covariance giving a joint probability function? Well, what we have here is that the probability distribution of the returns of a particular asset, right? So this a joint probability function of two different returns of assets will be able to give you the covariance of those assets, because you're talking about the average of each one, right? The deviations of each one. So that's what you need here, just to understand this concept, right? Don't get intimidated by the learning outcome sometimes if that's the case. In risk and safety criteria, which I think are the stars of this learning module here, okay? Portfolio Mathematics. All right, let's go straight to the point. Look at that. Correlation return. So covariance given a joint probability function, okay? So the portfolio expected returns and variance of returns, covariance and correlation. We already seen this, right, friends? We already seen this formula before. So let's put that in more, a little bit. There we go. That's the formula I want you to put in your pocket, right? The correlation from the covariance arriving on the correlation. That formula is very important in my opinion. All right. So let's see another example here, practice 2, the correlation and the probability function. Look at that. I'm not going to do the whole thing here because it's very complex, and I think it's out of the scope of the exam to get a question like that. If you want to learn how to do, right, from a joint table, come up with the correlation, right, you could, right, you can, it's well explained on the official material, but I don't think that's going to be a possible question because of the time consumption that you take to get it there. So look at that. I have two assets here. All right. Don't expect the covariance for 3 or 4 assets. There's going to be the maximum 2 assets, right? 2 returns, 2 variables. 3 stages and how the assets are going to perform on each stage. Okay. With that, I can get the expected return. Okay, the expected return is 20% times 2 plus 50% times 5 plus 30% times 8 for the asset 1, similar for asset 2. So that's what we call the weighted average probability. Each stage probability times the return on each stage give you the expected return overall, as you did on the previous video on the Bayes formula when you're looking for the earnings per share is going down. Remember that we did the probability of going down under recession, under a boom, under the normal, and then we average, and then you find the overall expectation. That's what you're doing here. All right. From that, I can get the deviations. Look, I have a deviation right here. I expect 5.3 and I got 2. I expect 5.3, I got 5. And I expect 5.3, I got 8. I have a deviation on each one of those. Each one of those deviations are going to be the X, or the asset 1 deviations. Then I do the same for asset 2 deviations. Multiply by one by the other. Divide, and then I can get the covariance of each one. And then from the covariance, I can get the correlation and create like a table. Okay, so look at that. We can get the variance, standard deviation, covariance, and then the correlation in the end. I'll take the covariance of each one, and I divide it by the standard deviation to get the correlation. Try to get comfortable with that table. Okay, not necessarily how did I get this 0.001736 and no, as the variance. What you need to understand is this: if the correlation here was empty, you didn't have this 0.87553 or the 0.95133, okay, would you be able to compute the correlation? That's more likely to be in a question in the exam. Okay, so that's what I put this there as example. Now, what do you think about, not on the question, like interpretation, what do you think about the correlation? 0.875, 0.951, large cap with the equities, right? Large cap versus the world, okay? So comparing, okay? All the large cap equities in the United States with the large cap outside the United States, there's a correlation of 0.87. It's a high correlation. You have to remind you that correlation goes from +1 or from -1 to +1. That's very close to 1. So is this one. It's even closer. The bonds, intermediate in time and long term, they are very correlated. That's what you can see here. That's the interpretation part of the questions that you may face in the CFA exam. All right, and let's finish this video with the risk and safety criteria. Okay, I think that's important here. So safety rules. So safety rules is this: how much the client needs. Great. Now let's see. Let's select portfolios according to how much the client needs. So it's based on safety. I need at least X% return every year. So based on that, I'm going to select portfolios. So look at that. The formula of the saved first ratio, or ROI's saved first ratio, is expected return of the portfolio minus the expected return required by the client divided by the standard deviation of the portfolio. It's a very simple formula. Let's do a quick example here for us to see that. Okay, there we go. So look at that. I have 3 portfolios, A, B, C. I have the returns, standard deviations, and I need to know which one of those 3 portfolios is the best one for a client that requires a minimum of 5% return. Look at that. That's the minimum required. Okay. Parentheses here, or that's a little note for you. Sometimes the minimum return might not be given as a percentage. You're going to have to look in the question and figure it out how much the client needs. For example, the client has a portfolio of $700,000, and at the end of each year, that person needs to pay this, this, and that. Then you have to add all those amounts, divided by 700, and that's how much is the minimum return required. So sometimes it could be that. Or they're going to just tell you the minimum return is, in this case here, 5%. Then what do? Very simple. I'm just going to do the difference between, okay, the return of the portfolio A minus the minimum return, 5%, divided by the standard deviation of portfolio A, okay, which is here. There we go. And I got 0.3. That's what I got, right? So 8 minus 5 divided by 10. Okay? 8 minus 5 divided by 10. The next one, I did the same calculation, 15 minus 5 divided by 12. And the last one, I did 18 minus 5 divided by 20. And now, which one is the best portfolio based on Roy's criteria? Is portfolio B. Okay, portfolio B has the highest, now let's put it there. That's the highest, okay, there you go. That's the highest safety criteria here of those three, the highest one. So that's the one you're gonna tell the customer, the client, let's take this portfolio that has a 15% return with a 12% standard deviation. That's the best one for you. Okay, simple, right? Very simple. Chances to be in the exam? Absolutely. Absolutely. A quick question, right? 3 portfolios, do a quick calculation, boom, find Roy's safety and answer the question. I think that's very likely, okay? It doesn't take a minute and a half to answer those questions. Another point that I always insist, that question that I just showed you, imagine how this question could appear in the exam. How could you be tested, right, on the safety first ratio? Conceptually or numerically? Numerically, right? Same for the correlation, the covariance. I don't believe that here that you're gonna have to calculate the covariance and the variance, but that's my opinion, okay? Then later on say, no, you know, it was a calculation, a variance calculation to do in my exam. Found, you know, difficult to happen, not impossible, but I also think that if you do find a calculation of covariance, right? When you have to do deviations, then multiplications, etc., all the steps, I found unlikely. But I also find if there is, if it will be there, will be easier, okay? It will be like very, very short, nothing too complicated, okay? Because we need, okay, what, a minute and a half. It's the average we have here, more or less, to do the questions. Good. Let's see if I covered everything and then finish this video, right? Because I told you it was relatively short. All right, calculate expected variance, deviation, covariance, and correlation. We already addressed that. Define shortfall risk. I did not define shortfall risk. Let's talk about that. Shortfall risk is the risk of the values being below the expected value. Below the expected value. In portfolio management, you're going to learn about the Sortino ratio. Okay, just going to mention Sortino ratio here. In the Sortino ratio, okay, it's a ratio that kind of like is going to focus on the downside deviation. Okay, it's just going to focus on the risk of the numbers expected being below the expectation. So the number that you get, the returns that you get in this case, would be below the expected return. Let's analyze that deviations only. The deviations above what I expected, it's not much of a concern. Okay, so we have a ratio for that. It's similar to Roy's, but we only focus on, let me go back here to you because what I'm saying here might be important for portfolio management down the road. So when we saw that example here, okay, right there, we decided to divide it by this standard deviation here, right? That's the Roy's safety criteria. But if I'm using the Sortino ratio, I will not use the standard deviation. I use only the downside deviation, only the deviation below the expectation, right? Which is usually given in the problem. All right? Well, I think that's enough. That's the key points here as well, okay? So one more time, that's the formula of the covariance. which I believe you just need to kind of have it in mind. And if you get a question like that, and if you remember the formula, then most likely you'll be able to compute the covariance using that formula. Okay. All right. I think that's good enough. All right, friends. So that's it. Portfolio Mathematics. Like I said, a short module. Okay. Here we're going to be very, very good that if you practice. So do as many questions as you can. Okay. And go to the examples on the lessons and try to see if, ask yourself, which kind of conceptual questions could I face from this module? Because we know the analytical questions, how they could be. Correlation, covariance, and the safety criteria. That's it. All right. I'm going to end in here and getting ready for the next one. The next one, it's also the next module. It's not a complicated one. Okay. It's going to be talking about simulation methods, and this simulation methods, it's going to be, in my opinion, very conceptual, more conceptual than analytical, and it's just, in my opinion, a preamble, or like a opening the door for simulation models that you're going to see, especially in fixed income. Okay, so I believe that the next video will not be so much of a concern on QM. I believe that the CFA Institute put this module there more to kind of like open the door for you. Say, listen, simulation is something important. Try to understand the basics now. Okay, but for this video, which was not about simulation, it was about portfolio mathematics, I am done. Okay, so any questions, you know what to do. Ciao, ciao, bye-bye.